Welcome all to the lab session on generative AI. Myself, Mrs. Madhu Nagraj, Assistant Professor, Department of CSE Data Science. So in the previous two videos, we have seen the first and the second lab program. So now we will start with the third program. So the program says train a custom word-to-vec model on a small data set, train the embeddings on a domain-specific corpus. That is, we can take two type of corpus, either you can take legal or medical, and you can analyze how the embeddings capture the domain-specific semantics. So the main thing which we are going to discuss here is about the embeddings and the corpus. So what do you mean by embeddings? So the vector representation or the numerical vector representation of any of the words is what we call it as the embeddings. And corpus means a set of statements or a set of sentences, which we call it as a corpus. So here what we are going to do is we are going to take up a set of statements related to the legal or related to medical, and we are going to analyze the embeddings. So we are going to train it with a small data set, and then we are going to analyze the semantics. So there is difference between semantic relation as well as syntactic relation. So semantic means where we are going to check the relationship based on the meanings. Syntactic means so based on the uh, grammatical relation we are going to check it. So here we are going to mainly check with respect to the semantics or the meaning. So here, whenever we are using the word-to-vec model, so we have the two types of word-to-vec model. One is CBOW, that is continuous bag of words, so which is mainly used for a larger data sets, and skipgram, which is mainly used for a smaller data sets. So whenever we use CBOW, it mainly predicts a word. So you will be having a set of words or a surrounding words. So from that, it is going to predict the word. But in skipgram, it is going to predict the context words. So it will be having one target word and it is going to predict the surrounding words. So in our model, we are mainly using the skipgram in order to analyze or in order to convert word to vec values. So now in this pre-processing, so that is whenever we are going to run this program. So first thing what we are going to perform is tokenization. So tokenization is nothing but when you have multiple sentences or in the corpus you have a set of statements. So each statement is taken and it is going to divide the complete sentence into individual words or individual tokens. So individual words are called as tokens. So it is going to perform that division and this is called as tokenization. So how you are going to perform, so what are the parameters, so which you can see here. So these are the parameters which we are using in the program. So let's see which are these parameters that we are going to use in our program. So this is the program. So first starting with, we are using the word2vec package that we are importing from the GenSim model. And then we have this simple pre-process. So this is the package which mainly helps in tokenization, that is dividing. This complete sentence will be taken and it will divide it into individual tokens, the code, rule. So each one will be individual. And then PCA and PLT. So PCA is mainly used for dimensionality reduction as we had discussed in the previous program. So dimensionality reduction where you want to reduce from 50 or 100 dimension to 2 dimension. So PCA means principal component analysis. And matplotlib is mainly used for plotting the graph. So here you can see, so this is the corpus. So mainly we have taken the legal corpus where you have a set of statements which are related to legal things, and then this is a corpus that is created. Now what I'm doing is I'm performing tokenization. So using simple pre-process, I'm passing these sentence in the legal corpus and I'm performing tokenization, and each of the tokens will be stored in my variable called as tokenized corpus. Now I want to build and train my model. So for my model, what I'm telling is for the sentences, we are taking the divided values or the tokens. And then my vector size is 50. That is, I'm taking a 50 dimension model. Window size is 3. That is, each time when you analyze the words, so first 3 words, then 3. So like that we are going to take. and minimum count should be 1, that is one word at least in the window. SG is equal to 1, so that means we are using the skip gram. So if SG is 0, then we are going to use the CBOW model. So epochs is 100, so each time when you train, so we are training with 100 epochs at a time, so 100 words at a time, and then we are saving the model. So whatever we have used now, so we are saving the model. So after that, now we are going to analyze the model. So we have trained the model, now analyze the embeddings. So take any one word from the corpus which we have trained here. So take any one word from this corpus. And then what we are doing is we are checking whether that particular word, this word is present in the model or not. So what we have trained now with the tokenization, we are checking whether that word is present or not. If it is present, then print the embeddings of that model, else print not found in the model. So it is going to print the embedding. So this is the embeddings for the word lawyer. So all the 50 dimensional embeddings or 100 dimensional embeddings are printed. Next, we are performing dimensionality reduction. So we are using PCA and we are performing dimensionality reduction. So take a few words from the corpus and then in the form of array and store it in the variable words to visualize. Now what I am doing is for each of these word in the words to visualize, I am going to convert that into vector forms and then store it in the variable called as word vectors. So once I say word vectors, then all the embedding values of these words are printed. So first one is for jury, next a court, next is for plaintiff, next is for defendant, next agreement, lawyer, evidence. So the embedding values of all these words are printed. Now all these are 100 dimensional values. So now we will reduce it. So we will apply dimensionality reduction and reduce to 2 dimension. So what I did, so convert or perform PCA, apply PCA and reduce it to 2 dimension. So when I say n components, that means we are specifying for how many components it is being reduced. So n components 2 means, so dimensionality reduction is applied for 2 dimension. So PCA fit transform. So it is going to fit all the words in the word vectors and reduce it to 2 dimension and then store it in the variable reduced vectors. So in reduced vectors it is going to store, and once you say reduced vector, so the 2 dimensional values for all the words specified is going to be printed. So here you can see the 100 dimensional values that is reduced to 2 dimensions. Similarly, after visualizing it, so in order to visualize it neatly, we are going to plot the graph. So first, fixed size. So that is, I am defining the plotting size of my graph. So 10 cross 8. Then I'm going to loop through all the words in the words to visualize. That is what we have declared. So loop through all the words and scatter one by one word in the graph. So I'm using the scatter graph here. So this is my x-axis and this is my y-axis. Then I'm going to scatter each of the word from the defined words. And then whenever you're displaying the text, what I'm doing is in the x-axis, we are giving a space of 0.02 so that the words don't overlap with one another. X-axis, y-axis, each of the word is taken with the font size 12 and it is printed. So this is the title of the graph, this is the x-axis label and this is the y-axis label. So this is title, y-axis and x-axis. So all the words are plotted in the scatter graph. And finally, we are going to find the similar words for the any of the word that is taken. So take the word to vec model, what we have trained, pass any of the words and then print the similar words. So most similar is the function that we are using. So when I say most similar for the word lawyer, so all the words, semantically similar words are printed. Carefully, claimed, jury, damages, negligence, documents. So top 8 values we are printing. So all the values will be printed. Okay. So this is about the program 3 where we are taking a small data set, training the model And then we are going to analyze the embeddings. So that is about the third program. Thank you.